Hello and welcome. I will just shortly demonstrate this predictive maintenance deep neural network model for machine tools. So today I will run it in a M262 PLC, which is a very powerful PLC, and you can run it also in a motion application and also very powerful logic applications. And also it includes IIoT protocols for cloud connection. So you have basically everything to run a machine in a modern days. So it's very nice to run also this neural network application there. So actually what you now can see there is visualization of this neural network. So what we have there is we have inputs there, and then we have outputs that are classes, or we have a no failure, we have overstrain failure. So depending of the machine tool input parameters, machine will function in a mode where there is no failure, or then some failure mode is predicted. So this is a quite illustrative visualization for this demonstration purpose. So, and what you can see here is a graph. This is actually probability of no failure. So when the this curve is blue, then the probability of no failure is over 80, and if it drops below that, it will go to red. Of course, you can adjust these kind of limits to whatever your needs are. So let's start. So what I'm right now doing is I'm running a test data set. So I'm just inputting different parameters to input, for example, air temperature, process temperature, rotational speed, torque, and then tool wear. And then I this visualization or graph is showing is there failure or not, and also what other failure modes, what is their probability. So they are basically, they are of course low here, but sometimes they are peaking depending of the input parameters. So this is just a test data for just showing how this graph is working. But now let's change to source to visualization, so then I can adjust these parameters. So I will change the source. Okay, now I will change to visualization. So now I can adjust these parameters wherever I want them be. So let's start to adjust. Well, now we see that we have no failure, and the probability of no failure is basically 100%. Or 1. So let's start to change these parameters. Let's say I will change the air temperature with these parameters. This probability will go below 80%, and then there is a heat dissipation failure rising. And well, it's quite reasonable if we are changing air temperature. Then probably there is some heat dissipation problems. And let's start to increase the process temperature. Well, for in this case, it has an effect that probability of no failure goes to again the max. So this was a good. Then let's start to change rotational speed. Okay, when when changing rotational speed, I can see that power failure is rising. Yes, that's very reasonable. Also, let's put it back. Then I will add some torque. Putting more torque, again, power failure. Well, let's put these parameters down. Then I will increase tool wear, so I'm kind of running a more used tool. So this has been used now over 300 minutes or maybe 300 minutes or 5 hours. So now let's see. I have a quite used tool. So let's see if I just drop a bit these parameters. I have to increase process temperature for getting back to good area. And if I decrease process temperature, now let's come to this proposal or prescriptive maintenance part. So now I have here a proposal. What should I adjust in order to get no failure back to the right zone? So let's see. I have well, increase rotational speed. Let's try increase rotational speed. It seems it's going okay. Well, now I'm back in a right zone, so I have no proposals there. Let's start to increase air temperature. Well, then I have proposals. What should I do in order to get to no failure mode? I have here, for example, well, increase process temperature or increase rotational speed. Let's try to increase rotational speed. Yes, so I'm back in a kind of comfort zone. So what? So we have a predictive maintenance telling about with these inputs, with these parameters, probability of failure or what failure mode will come if these parameters are kept. So, but added to that, we have also proposal what if we are in a zone where the failure will come, then we have a proposal what parameters we should adjust. So this is a very nice feature. So what could be actual application? We could adjust according to this proposal these parameters automatically. In software, we would have some rules what parameters we can adjust with the current parameter settings. Of course, it will need a lot of rules or program, but it's doable anyway. So in that sense, and then we have a digital twin dimension for this also. So let's say that we would have a situation that our failure would be no failure would be below limit, and there would be some failure mode rising. Well, what could I do? I could with this model, I could also to simulate without machine could be running there, but I would in this program I would simulate at the same time what should I do right now in order to get back to right. So I would have a simulation or virtual model of my machine, and I could run some parameters changes and see the result, and according to the result I could then adjust some parameters in order to get machine running in a comfort zone. So this is one dimension of this application. How can this neural network model can be used for machine. So I think all the essential parts were here. So thank you, and demonstration will end.